All right, guys, let's go ahead and take a look at this next problem here. So this one says a toy cannon fires a yellow marble up and at a certain angle. The marble lands 2.24 seconds later after traveling a distance of 13.44 meters. What was the marble's initial velocity in the x direction? What was the marble's initial velocity in the y direction? What was the total initial launch velocity of the marble? How much time does it take to reach the apex? And then what is the maximum height reached? Okay, so there's a lot of information that we're talking about right here. All right, so let's go ahead and fill out this table. But before we do that, we need to draw a picture just like we've been doing. So here's my marble, and it's launched at some angle here with some velocity. It says it moves through the air and lands a distance later of 13.44 meters, and it takes 2.24 seconds to do that. Okay. So my initial distance in the x is 0 because my origin is always going to be where I'm starting, which is right here for the angle launch problems. Positive x to the right, positive y up. All right. The initial velocity in the x, I don't know. The final distance in the x, I do know. That is 13.44. The acceleration in the x is 0, and then the total time is 2.24. Let's take a look at the y direction. Well, in the y, I'm starting at 0. My final distance is 0 because it's landing at the bottom. The initial velocity, I don't know. The final velocity, I don't know. Acceleration should be negative 9.8. Okay. So we got enough variables here. We can go ahead and get started. We could start with the x or the y. I'm going to go ahead and start with the x because I think that one's slightly easier. So for the x, I'm going to solve for VO. In order to do that, I'm going to use Big Dog. So Big Dog says df equals do plus VOT plus 1/2 AT squared. In the x direction, this whole thing is 0. So I'm just left with df, which is 13.44, is equal to, do is also 0, is equal to VO times t, which is 2.24. In order to solve for v, I'm going to divide both sides by 2.24. Doing so is going to tell me that the velocity in the x direction should be 6. So I'll write that here for the initial velocity. Well, if I know the initial velocity in the x, I also know the final velocity in the x because acceleration is 0, so the velocity in the x is not changing. So the final is also 0. Oops, by 0, I meant the final is also 6. All right. Next one is solve for the initial velocity in the y direction. So we could do the same thing. We can use the same equation. It's the only way to do it. So let's do that. df equals do plus VOT plus 1/2 AT squared. So df and do are both 0 here. So 0 is equal to 0 plus my velocity, which I don't know. So v is equal to something. That's why I'm just going to leave it as v, times my time, which is 2.24, plus 1/2 times negative 9.8, and then times my time again, squared this time. Okay, so I got to do a little bit of simplifying here, which makes this a little bit more difficult, but it's all right. It's not too bad. So let's bring this guy over to the left side so we have one thing on one side and one on the other. So we have negative 2.24, because I'm subtracting it over, times v is equal to 1/2. So 0.5 times negative 9.8 times 2.24 squared. That's going to give me negative 24.59. All right. And then in order to solve for v, I'm just going to divide both sides by negative 2.24. After doing that, I find out that the velocity in the y direction should be 10.98. And velocity is a measurement of meters per second, so we'll just tack on those units. If I know my initial, I also know my final. It's going to come down with the same velocity. So instead of positive 10.98, it's going to be negative 10.98. So let's start filling out some of this information up above. So the initial velocity in the x was 6. The initial velocity in the y was 10.98. Next, it wants to solve for the launch angle. That one's going to take a little bit more work. So if we look at what we have here, we have x and y there, and we have v. It kind of looks like a triangle, but we're going to redraw it so we have our triangle. So we have velocity in the x, which was 6. Then we have velocity in the y, which is 10.98. And then we have our final, or our total initial velocity here, vt, and our angle. So in order to solve for vt, we're just going to use Pythagorean theorem. So vt is equal to a squared, which is 6, plus b squared, which is 10.98 squared. We know that this is equal to the square root because a squared plus b squared equals c squared. So we have to square root the whole thing to solve for c. Doing so, that's going to give us our total velocity, which the total velocity in this case is just going to be 12.51 meters per second. Now that we have the total velocity, we can solve for this angle in here, which we could have solved for it before without the total velocity, but this just makes it slightly easier. So the total velocity, since it's the angle, we're going to need to use a trig function here. I'm going to go ahead and use inverse tangent, because this way I know that my Vx and Vy are most likely right, but say I did make a mistake there, and then if I calculated Vt with the wrong ones, I'd be even more off. So I'm just going to stick with these guys. So we know that inverse tangent is opposite over adjacent. So in this case, it would be 10.98 divided by 6. And that's going to give me the angle that I'm launching my projectile at. So the angle in this case should be 61.34 degrees. So let's go ahead and fill that information out above. So the launch velocity was 12.51 and the angle was 61.34. How much time does it take to reach the apex? Well, if it takes 2.24 seconds to go the whole distance to reach the apex, it's going to take half that time. So I'm going to go ahead and take my total time and I'm going to cut that guy in half. Doing so is going to give me 1.12 seconds. What is the maximum height achieved by the ball? Well, that's going to take a little bit more to solve for, but it won't be too bad. So to figure out the maximum height, that sounds like I need df. So I'm going to use my big dog equation again. df equals do plus vot plus 1/2 at squared. So before I plug my numbers in, I just need to make sure I'm using the right numbers here. So my velocity is my initial velocity in the y, which doesn't change even though I'm cutting the time in half. It's still the same initial velocity that I'm launching at, so that should be 10.98. What does change, however, is going to be my time. Instead of having 2.24 seconds, it's only going to the apex, so it's just 1.12. Now that I have this stuff figured out, I can go ahead and solve. df is equal to, well, do is just 0. VO is 10.98. Time is 1.12. So I'm going to multiply those two guys together. Plus 1/2. A is negative 9.8. And T is 1.12 squared. Plug all this into my calculator, and I find out that the maximum height that my ball or marble reaches is 6.15 meters. All right, and that wraps it up for this problem.